Can A be a 5? Well, if A is 5, then we want a number 5b, which when multiplied by a single digit number c yields the 3-digit number 555. 555 can be written as 5 times 111, which is 5 times 3 times 37. Now, can you construct a factor of 555 which is between 50 and 59? Well, I don't see how you can do that, because 5 times 3 is 15. 15 is much less than 50, which is the smallest possible number with this format. And if you try to combine 37 with any of the other factors, the result is going to be much more than 59, which is the largest possible number with this format. So it doesn't look like there exists a factor of 555 between 50 and 59. So A cannot be a 5. Can A be a 6? Well, let's see if we can find two numbers 6b and c whose product is 666. 666 can be expressed as 6 times 111. So we can split up 6 into 2 and 3, 2 times 3. And as before, we can write 111 as 3 times 37. Now, let's try to see if we can find a factor of 666 that's between 60 and 69. If we multiply 2, 3, and 3, the result would be 6 times 3, or 18. 18 is much less than 60. And if we combine 37 with any of these other factors, we would get a number that's at least 74, which is 37 times 2. And 37 times 3 would be 111, which is more than 69, which is certainly more than 69. So there doesn't appear to be any factor of 666 between 60 and 69. So if were to be equal to 6, then we wouldn't actually have any legitimate values for the letters B and C to make this operation a correct multiplication operation. So A cannot be a 6. Can A be a 7? Let's see. Can we find two numbers 7b and c whose product is 777? Well, let's factorize 777 into its prime factors. So 777 is 7 times 111. 7 is already a prime number. So we can factorize 111 into 3 and 37. 3 times 37. Now, can you find a factor of 777 that's between 70 and 79? Well, 37 times 3 is 111, so that's outside the range that we want, from 70 to 79. That's already much beyond 79. And 37 times 7 is of course going to be even more larger. 7 times 3 is 21, and 21 is smaller than 70. So there doesn't exist any factor of 777 that lies between 70 and 79. So A cannot be a 7 either. What about 8? Can A be 8? Well, let's see if we can find two numbers 8b and c whose product is 888. Since 888 is 8 times 111, since 8 can be written as 2 times 2 times 2, and 111 can be written as 3 times 37, we get the following prime factorization for 888. Now, can we detect a factor of 888 between 80 and 89? Well, if we take 37, and let's say we try to combine 37 with one of the other factors, we combine it with 2. 37 times 2 would be 74, which is less than 80. 37 times 3 would be 111, which is more than 89. So certainly we cannot combine 37 with any other number to form a factor between 80 and 89. Let's try combining all these other factors together and see how large a number we get. 2 times 2 times 2 is 8, and 8 times 3 is 24. But again, 24 is less than 80. So 24 cannot be this number. So it doesn't appear that there is any factor of 888 between 80 and 89. So a cannot be an 8. Finally, let's look at whether a can be equal to 9. Can we find two numbers 9b and c whose product is 999? Well, 999, which is 9 times 111, can be factorized as 3 times 3 times 111 is 3 times 37. So this is 9, this is 111. So let's try to see if we can combine some of these to form a number, to form a factor of 999 between 90 and 99. 90 is the smallest possible number which satisfies this format, and 99 is the largest possible number with this format. 37 times 3 is 111, which is already beyond 99. So clearly we can't combine 37 with any of these threes or combinations of threes to form a factor between 90 and 99. What if we just combine all the threes together and see how large a number we get? 3 times 3 times 3 is 27. 27 is unfortunately much smaller than 90. So we don't have any legitimate values for B and C here, such that 999 can be factorized into some number 9b times C. So A cannot be a 9 either. So we have enumerated all possible values of all possible digits that the letter A can represent, and we saw that there was only one solution that we got where A was 3, B was 7 and C was 9, where the resulting multiplication operation is actually correct. So the only solution to this cryptarithm, AB times C yielding the product AAA, is 37 times 9 being equal to 333. So A is 3. I'm sorry. Can A be 3? Yes, A can be 3. So A is 3, B is 7 and C is 9.